Question number 16 on 3.3, asking to sketch the graph of y equals 1 over x squared plus 2. That's the original function. And in the B, section B, it's asking to sketch the final image after a series of transformation. Okay, so then first we graph this. This is the rational function. We can see we should have, you can actually focus on this part, y equals 1 over x squared. And if you graph this, you should get a vertical asymptote at is the y-axis. And then the x-axis would be the horizontal asymptote, because when x approach to infinity, y is going to be 0. And the plus 2, you can treat it as a transformation, the 2 units up translation from the y equals 1 over x squared. So that's why we have 2 units going up. So you end up getting the horizontal asymptote is y equals 2. Okay, then let's look at what kind of transformation the graph has to go through. So the first step is the vertical stretch by a factor of 2. If you do this, basically the rule is the y is going to be replaced by 1 over 2y. Now, this means the original function is going to undergo this kind of change. But it doesn't mean the y-coordinate on the new graph is 1/2 of original. In fact, it's just the opposite. Okay, so we explained that in the previous class. If you try to isolate the new y, you're going to get the new y is actually equals 2 times of the original y. So that's why when the stretch by a factor of 2 and y is actually replaced by 1 over 2y. And then the reflection in the x-axis, that's going to be a vertical reflection. So you just change the y into negative. So because we already got 1 over 2y, so it should be replaced by negative 1 over 2y. So that's a vertical reflection. And then finally, a horizontal compression by a factor of 1 over 2. That's the same reason. And then x should be replaced by the 2x. So the 2 here is always the reciprocal of the 1 over 2, just like we did here. Right? What if it's a compression by a factor of 2 over 3? Okay, and then x should be replaced by the reciprocal of 2 over 3, which is 3 over 2. Okay, that's just a little bit complicated. Okay, now if you understand y and x will both be replaced by a different term, and then we just simply do the change. See, y is replaced by negative 1 over 2y, and x is replaced by 2x. Now just be careful when you have x squared. So it's 2x is going to be the new x, so which should be squared as well. So don't just put a 2, left as 2 out of the square. So that's going to be wrong. And after you get this, you need to understand the function is totally changed to a different new function. So if you compare to the original one, it's totally changed. Just so we can trace how it's transformed, and we can make a connection and compare to the original function. So that's why we're learning the transformation, right? So it is a new function, but somehow related to the original. And of course, we can simplify this, and by multiplying negative 2 on both sides of the equation, and of course you need to square this, becomes 4x squared, and after you, then you just multiply negative 2 on the right side. Eventually you should get this. Okay, so that's going to be the new function. And then if you check the graph, and basically you understand, first of all, we have a vertical stretch, so that's why you see it becomes skinny, right? Skinny. And of course, when we have horizontal compression, if you horizontal compressed, actually you make it at if you have horizontal compress, all the points is gonna come to this way, and it's very similar like you have a compression, vertical compression. Now this is a little bit complicated. I may explain in a different case. But anyway, the combined effect of vertical stretch and horizontal compression is going to eventually make it having horizontal compression. Okay, because they kind of cancel each other a little bit, but because x is squared, so eventually it's you can see it's either you think it's a vertical stretch or horizontal compression. So you can see it's this one skinnier, right? Of course, you can see the reflection, right? That's why, and the reflection because also you have a vertical stretch. So, and then the horizontal asymptote is actually from change from y equals 2 to y equals -4, right? Because stretched doubled. Okay, so that's the original function.